Rock and roll. This is a pickup coil from an electric guitar. And I hope that you can see that there are 1, 2, 3, 4, 5, 6 magnets right here. Let's prove that they're magnets. Yep, stuff sticks to them. And each magnet is designed to magnetize a string of the guitar. So the strings will be like, well, the pickup would be like that if the strings were like this, doom, 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 in front of it, and you go like that, and it would be awesome. Or we could show it like this, and I think that might make the most sense. This coil here has 500 or so turns. Wow, that's a lot of turns. What is this pen thing? Okay, here, let's get a marker here. We're talking about 500 turns or more. And out of this just comes 2 wires. So let's talk about how rock and roll is made. I'm gonna zoom in on just one of these magnets. The magnet's like this, and it has a north pole and a south pole. I don't actually know if the north pole is the one that's sticking up, and I frankly don't really care. But there is a coil going around it like this. Lots and lots of turns. Hundreds of turns, and the coil comes out and goes out, and yeah, so it's got 2 leads leading from it. But in front of the magnet lies a string, and from our perspective, the guitar string is sliced and would appear right there. I guess it's gonna be a little bit smaller, but I wanted to show you that when the string is nearby the magnet, then the string becomes magnetized, and you can bet that it would prefer to have this side be south and that side be north, assuming it's a ferrous material. So we're going to set it up like this, and then if you hit the string, boom, you hit the string, that string will shake back and forth, which in turn will change the amount of flux going through this coil. Now, does this coil like having its flux change? But the coil is monitoring the change in flux at every instant. So it's getting this derivative of the flux as a function of time, and it's multiplying that by the number of turns that we've got. So this is a big deal, and then putting a minus sign on it to find the induced voltage on the coil. So the coil is spitting out a voltage function that's sometimes big and sometimes small and sometimes big and sometimes small as the string is vibrating up and down. And we're probably going to get a graph that looks kind of like this. V induced as a function of time will be like this, and the frequency, well, this is like a period or something, and 1 over that would probably be the frequency, but the frequency will correspond to and be exactly the frequency of the vibrating guitar string. So the information about how the guitar string is vibrating is carried in the induced voltage. And this is awesome because now you can amplify this and send it around, and then you can then hear the movement of the guitar string without having to have any sound come from the guitar string and be amplified through the body of the guitar and then come to your ears. So it could just be immediately recorded, or it could be amplified and then played back on speakers, etc. So let's make a little schematic diagram of what we've got. We've got a guitar, and I suppose it has to be an electric guitar, and then we can send the signal from the guitar to some pedals, and those pedals can change the sound in a lot of awesome ways. I'm only beginning to explore that. You probably know more than I do about it. And then we'll go to an amplifier. So you're talking about Fender or Marshall or something. And these guys are going to make your sound louder. Not your sound, I should say your signal. So they're going to take a small induced voltage, and even though there are 500 turns or so here, we're going to say that this voltage is rather small, probably in the millivolt range. And they're going to make it in the volt range. They'll make a much, much larger voltage change coming out of that sucker, coming out of the amplifier. Then the amplifier will send the signal to a speaker. If it's not being recorded, it's going to be sent to a speaker. We'll talk about speakers in just a minute. But before we talk about speakers, I want to ask you a couple questions about guitar. For instance, would it work with nylon strings? Electric guitar with nylon strings. Nylon is a kind of plastic. Answer is no. Why not? No. Why not? You figure it out. And would it work with copper string? Electric guitar with copper string. What if you, what if you are looking in some fancy magazines and they say that they can get you gold strings, and well, gold doesn't have that much tensile strength, but what if yeah, you got suckered into something silly like gold string? Would that work? And you can figure that out. Turns out only a few things will work, and you should discuss that in the comments. But let's talk about the sound you get out of the electric guitar. So if you've got a choice between two strings and one of them's like this and the other one's like that, assuming they have the same density, which of these two strings is going to have more acceleration if you pluck it? I'm going to argue that low mass means higher acceleration. I'll just write big acceleration. And another thing that could make our acceleration big might be changing the tension. Would you want tension high or tension low? Big acceleration of the strings. What kind of tension? Oh yeah, you want high tension. High tension would lead to a big acceleration of the strings, because really tension is a force, and it's a restoring force on the string. If you think about the string being like this and there's a lot of tension, if you just plucked the string that way, then it will want to get back to where it was much more eagerly when it has high tension. It'll go back, it'll actually go to right here, and then it'll vibrate back and forth, and this is the first note. You've studied all that stuff, but I just want to think a little bit more about rock and roll. What about if I have more acceleration? Does that mean faster or slower vibrations? What do you think? I'm guessing that'll be faster vibrations. Sure, because more acceleration means that you can change your velocity more quickly, so that means the vibrations can be faster. What about pitch? Pitch is an interesting idea. If you have a faster vibration, does that mean higher pitch or lower pitch? Faster vibration leads to higher pitch, in fact. This is why when you hit things that are thin and light, like crystal glass or something, you tap it, it goes ting! And when you hit a deep, heavy bell, it goes dong! So the big heavy bell has more mass and obviously has a lower pitch as a result of that. So that's cool, but it's time to talk about speakers. Once you've gone from the amplifier and you're ready to hook up a speaker, then, well, I'll show you a few speakers. You got little speakers like this, and you got medium speakers. Actually, most people would consider this a reasonably big speaker. Big speaker like that. And then you've got big speakers like this guy right here. Somebody busted out the foam surround on that, but it's still a rather big speaker. On the back of all the speakers, you see a magnet. See that? Yep, cool. And there's a magnet even on the back of this little guy. It's kind of a weak magnet. Come on. Oh, there, you can see in the middle. All right, good. So I want you to notice this thing in the middle. The speaker moves in and out, and that's how you hear the sound. That little papery thing in the middle is called a voice coil. This speaker's been busted out a little bit so you can see it. But in this guy, they put a little cover over the voice coil so you can't see it. But you can see the leads going in. Those two leads are going into the voice coil. Now the voice coil is simply a piece of metal wrapped up like this. It's like this direction, and it is a coil in much the same way as the pickup. You're going to see all kinds of analogies to the pickup right here because it's kind of doing almost the exactly same thing. And I'm going to give you a magnet. There's always a magnet in a speaker. You've got the north side and the south side. I'm just kidding. Some speakers are done without magnets, but those are really expensive and rather awesome. I love those kinds of creative ideas. Now I'm just going to be talking about a standard electromagnetic speaker. So there's a magnet here, and it usually fills the voice coil entirely. Like in this case, you see my voice coil is the paper cone right here, the paper cylinder, and right inside of it and completely filling it is a magnet right there. So you've got this big magnet and you've got this sucker here called a voice coil. And the plan is that when you send a big voltage through here, signal comes in here, and when you send a big voltage through it, you'll get a big current, and the big current will cause the voice coil to become a magnet. And the voice coil will either be facing the right direction, like this would be north and that would be south, in which case there would be a force that way. And so the voice coil would be pulled in, or the voice coil could get a current the other direction, in which case you'd have a south here and a north here, and then there'd be a force that direction on it because it's a magnet facing the wrong direction compared to that guy right there. Now that's cool. I can now put a signal into this voice coil and make the coil go forward and back. If you then take a cone of paper or plastic, were you ever asked this at the grocery store? And that cone then is attached to the voice coil, so it moves with it, and it can move in and out. And the beautiful thing about it is if we go all the way back to the guitar string is vibrating at the same frequency, as the cone of the speaker. So you are now getting information from the shaking of a small metal string out to the cone of the speaker that is slapping the air. Then the air gets slapped back and forth, that transfers that information through a wave, through the medium of the air, to your ear, and your ear can sense it, and hence, rock and roll. Rock and roll. This is a pickup coil from an electric guitar. And I hope that you can see that there are 1, 2, 3, 4, 5, 6 magnets right here. Let's prove that they're magnets. Yep, stuff sticks to them. And each magnet, this coil here has 500 or so turns. Wow, that's a lot of turns. What is this pen thing? Okay, here, let's get a marker here. We're talking about 500 turns or more. And out of this just comes 2 wires. So let's talk about how rock and roll is made. I'm gonna zoom in on just one of these magnets. The magnet's like this, and it has a north pole and a south pole. I don't actually know if the north pole is the one that's sticking up, and I frankly don't really care, but is designed to magnetize a string of the guitar. So the strings will be like, well, the pickup would be like that if the strings were like this, doom, 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 in front of it, and you go like that, and it would be awesome. Or we could show it like this, and I think that might make the most. There is a coil going around it like this. Lots and lots of turns, hundreds of turns, and the coil comes out and goes out, and yeah, so it's got 2 leads leading from it. But in front of the magnet lies a string, and from our